Thanks everyone for coming. I appreciate not all of you want to come in here and listen to an English speaker. Or certainly not someone from Northern England anyway. My accent is a little bit strong. If I do start to speak really quickly, then just shout out and tell me to shut up and I'll slow down, okay? Your English is way better than my Swedish, so I have to stick with what I know. This session, I know on the agenda, it was kind of listed as the sausage factory session. There was no real abstract, and that was because it was kind of put together really to try and give an impression of how Microsoft handles Office 365. So I'm assuming you're all Office 365 customers, or perhaps SharePoint on premises, perhaps a mix of both, or even considering Office 365. So what I'm hoping to do here is give you a view of how seriously Microsoft takes the platform. You know, Office 365 running services for Microsoft is a relatively new thing. Okay, we've done it for a long time. This is a new thing for us at this kind of scale. So I just want to give you an impression of what we do, how we handle things, how people get involved in the processes, how when things break down, how seriously we handle it, and how much we invest in the people that are going to deal with problems to make sure they get fixed quickly, and to try and make sure those problems don't reoccur. So we call it a view from the sausage factory, really just to give you an impression of what's going on inside. Just to let you know, this works. Helps if I plug it in. Just to give you a little bit of information about me, hopefully. There we go. So I've worked with SharePoint for a long time, really before SharePoint was around, kind of when Tahoe Server and SharePoint 2010, Team Services and those kind of things. Back in the day, then I worked for a company called CSC, or Computer Science Corporation, and I was kind of their global SharePoint specialist, if you could call it that back then. I then moved to Microsoft in 2005, where I worked with, I know at least one person in the room, who was also a PFE for a long time, so a field engineer, effectively the people that get parachuted in to fix problems when things go really bad. And then throughout my Microsoft career, I've really done all kinds of things. So I was actually an escalation engineer in the 365 team. So the painful things I'm going to talk about as part of this session, I've experienced firsthand. So when I talk about how the escalation processes work, how we handle situations, how we engage people in on-call situations, I've been at the sharp end of that. I've felt the pain, so I understand it. And then now I'm a product group member, so I joined the Office 365 CAT team in the middle of last year. And that team is primarily responsible for ensuring, I guess to put it in a very simple way, we want to make sure all our customers have a good experience. And that implies to on-premises customers and the Office 365 cloud-based people. So we kind of get to see everything. And if any of you upset me today, I used to work with drugs, poisons, and explosives for a number of years, so just be very careful. And that's me in a nutshell. So contact details are there if you need to get hold of me after the session. What I want to do is kind of just get a feel for who in the room is actually an Office 365 production customer. They have their main business running on Office 365, well, perhaps not the main, but certainly businesses, or a reseller, or who is not on 365 at all? One or two. Okay, well, hopefully we'll change that view by the end of these 2 days. So just to give you a feel for this session, this slide, really is to talk about what Microsoft invested in terms of the deployment that we've built and the scale that we've built to. So these numbers are actually fairly old. We've moved on a little bit, but we've moved on in two different ways. Yes, we have more actual servers on the ground these days. These are about a year old, possibly, these numbers. But that's because we have more customers, but we've also improved our efficiency. So while we're moving towards this process of saying, yeah, we want to get everybody in the cloud, we know it's well, some of us realize it's not necessarily a realistic expectation, but these numbers like 13,000 servers is actually kind of creeping down because the scales that we're building to, we can get more power out of the machines, we can get more tenants into individual farms. And what we found is that as we built the system, we basically said, we need a system that's going to work for everybody. We don't yet know what those customers' usage patterns are going to be. They could hammer the system 24/7 and really, hurt it in a big way. So let's build it massive. Let's go the whole hog. Let's put far more database servers in than we need, bigger network pipes than we need, more servers than we need, and then find out later whether we can start switching things off. So the idea was to give people all that upfront capacity and make sure that people hopefully have a good experience. and then slowly rein things back to optimize what we need and get the right level of density to match the customer usage patterns. So the numbers that we have, I mean, 37,000 SQL databases, that's huge, right? We run about 30, in the cloud, we run about 60 production farms. We can handle approximately 100,000 tenants per farm, just to give you an idea of how big this thing is getting. The tenants are in the millions. I'm not talking about users there, I'm talking tenants. So if you're an E3 tenant with perhaps maybe even 10,000 users, we have over 1 million of those, not necessarily that size tenant, but certainly over 1 million, creeping towards the 2 million in terms of the total number of tenants that we have on the system. And they vary between trials. Everybody spins up a trial to see what it's like and find out about it. And obviously we have to count those as well. But in terms of production licenses, it's a significantly big investment. It's a significantly big platform. And to add to that, were any of you formerly BPOS S or BPOS D customers even? So BPOS D is still around as Office 365 dedicated, but if you work with BPOS S, if you suffered the pain of trying to work with BPOS S, as at least one person in the room has, this has outgrown BPOS S by a factor of 8 already. And it's not as mature as BPOS S was, if you like. BPOS S was around for a long time. The other thing we have is 70 developers directly on call. So I'm going to talk a little bit about the escalation process later, but the reason for that is because we want the people that write the software to feel the pain when the software breaks. So we don't want a number of levels of escalations. If any of you have called in a support call for Office 365, then you know sometimes it gets dealt with very well, sometimes it gets dealt with very quickly, sometimes it takes a long time. When it's a major incident, for example, the provisioning engine. So if any of you have gone into 365 and you go create new site collection, if you've used SharePoint on premises, you sit and wait and the little wheel spins around and then it's done. If you do that in the cloud, you go and create a new site collection or a new site, you get a little message saying, come back, your site will be ready in a few minutes. That process is called the provisioning engine. Up until recently, that provisioning engine was done in a central farm that controlled all of the provisioning. And it was horrific. It used to break down all the time and we'd get escalations all the time and it'd be painful. So we decided to switch the developers who wrote that code to do that process, put them on call. So when it breaks down at 3 o'clock in the morning, they're the ones on the end of the phone. They feel the pain of what we were feeling in the escalation team because our customers were freaking out because everything was falling to pieces. So call them up, they get the problem, they see the pain it's causing for everybody else and now causing for them, so they're motivated to fix it because they don't want calling at 3 o'clock in the morning. So the idea of putting the developers on call meant that we've significantly reduced the systemic problems in the product because people are now motivated to get them fixed. So it's pretty huge. 9 global data centers, which is all we disclose. There's actually at least 3 times that amount in various places around the globe doing different things. But 9 are the ones we talk about when we think about Office 365. So the LATAM one, the 4 in the States where there's actually about 12. There's 2 in Europe where there's actually about 6. And underneath the orange panel here, there's actually Singapore, Hong Kong, and we're moving slowly into Australasia as well. Just to give you a feel for the global footprint. Now when we come to look at the data, this might actually play. Will it play? Yes. So this is trying to get a view of our metrics. So one thing that we're very interested in is where are all our users? We know where our data centers are, but where are the users and where's the traffic coming from for the users that are using those data centers? So if you look at the big orange circles, this is trying to give you an impression of where most of our user base is accessing the platform. So you'd probably say, well, looks like we could do with a data center in India, for sure. We have data centers in Europe, as we know about. We just opened a new one in Finland. Not in America, if you consider the data centers in the previous graph, the previous slide, Northwest, California, Texas, and then the East Coast, we have data centers in all those places. So data centers right where the user traffic is, right where the people are using the system. And we know we've got flaws. We know we don't have anything really in Australia right now. China is growing huge. There's been lots of press about the Microsoft investment in data center technology in China and the restrictions that we have there around privacy laws and the Chinese almost governmental paranoia around what can and can't go in and out of the country. Microsoft are the first people that have actually developed a relationship and a process that we can have our own Office 365 instance, if you like, sat inside the Chinese national border, managed by Chinese people, operated by Chinese engineers, who only escalate beyond those boundaries if they have a real major issue. And even then, the boundaries are such that I as an Office 365 escalation engineer, can't just log in unknown to that Chinese environment. I have to go through hoops. I have to request access to security groups. I have to do screen shares even, so that everything I do if I go to that environment to help them out is being recorded and monitored, just to meet their global privacy laws. But it means we can now move into China. And that, if you think about it, think about the next step, Germany. They have big issues with not issues, but they have quite strict national laws on data regulation and privacy. The Chinese experiment, if you like, you could call it that, gives us that first step of saying, well, why don't we do that in Germany as well? Why don't we do that in England for the national health services, where we have, again, similar kind of privacy laws? And all around the globe, there's all these countries that have these national regulations and Patriot Acts and what can't move where, and it gives us that first kind of investment to be able to say, yeah, we can bring Office 365 to you if you can't come to us. So it's kind of a step forward. Having said all that, what I want to do really is go into the details. So I'm going to cover, these are the kind of main 4 subjects I'm going to cover, and feel free to shout out if you've got any questions. So I'm going to talk about the zero downtime. How do we do high availability? How do we do the whole business continuity management strategy and protect your data and ensure that you as a customer can trust us to look after your data and know that the right people have access to it, or in 99.999% cases don't have access to it, which is what you really want to know. The always up-to-date side of things, and then secure and compliant. So the security and the compliance thing, we could do an entire subject on that, of how we ring-fence the environments, the hoops you have to go through to get access to the environments. And I mean, like I said, I used to be an escalation engineer in the dedicated side of things. In theory, I still have access to the dedicated side of things, but what I'm going to do at the end of this is if we have time, hopefully we will, I'm going to tell you the hoops that I have to jump through to get access to an Office 365 dedicated platform, and how I can get access to the SQL servers and to the SharePoint servers, completely audited, completely monitored, and completely tracked in terms of people knowing everything I do. So, and it's hoops and hoops and hoops I have to jump through. I can't just go an RDP into a box. It isn't going to work like that. So, zero downtime. What does zero downtime mean to anybody? I mean, think about when you're patching servers. Has anyone in here patched a SharePoint farm? No. Okay. Andrew at the back was patched a SharePoint farm. Okay. You've all heard this war stories, I assume. It's a horrible, horrible process. So it's very difficult to have zero downtime with SharePoint. Whenever you patch something, whenever we modify the DB schema, we have some workarounds, and we can, okay, we're going to move all your data to another farm and put you in a read-only mode while we upgrade your primary farm, and then we'll swing you back again. But it's a horrible kind of convoluted process that's really kind of difficult to manage. What we've done in the 365 side of things is really think about zero downtime from patching, zero downtime from availability, and you as an end user, or you as the company owner, want to ensure that your business is going to run fine, your users have access to their data, your users can launch the Office platform when they need to, they can access their SkyDrive when they need to, SkyDrive Pro and things like that. So what we've had to do is build in a whole series of monitors and capability that allows us to detect when anything goes out. So as soon as one component in the whole thing fails, there's the right level of alert goes off, the right level of people get involved to get it fixed, or the right level of automation gets invoked to fix something. And we think about the zero downtime side of things. All the places we'll have. Does anyone do SCOM? Anyone in the room work with SCOM? So System Center, you're familiar with creating management packs or deploying management packs, where Microsoft provide, if you're not familiar with that, Microsoft provide this product and these components and these features that say, I can roll this in, I drop an agent on my servers, and that agent is monitoring various things. So it detects, like, am I running high CPU? Am I running low memory? That kind of thing. And it sends alerts. That isn't good enough for Office 365. It's not quick enough. It's not granular enough. And when we're thinking about protecting hundreds of thousands of people and services, servers, databases, entire data centers, we need something that reacts much quicker. And we also need something that behaves differently. So do I need to know if one of my CPUs is running really hot? Well, maybe. Does it really matter? I don't know. One server in a farm running hot, maybe. Load balancer will handle that and direct traffic somewhere else. What if a user experience is running really poorly as a result of that? How do I know that? How do I know my searches are slow? How do I know my homepage load time is slow? And those are the things that we really care about. So we had to build synthetic monitoring systems. And hopefully I'm going to show you some of these in a demo, whereby we look at what users do and we say, okay, well, a user might upload a document. That's a pretty typical scenario. They might download a document, load a homepage, go to a search center, do some searching, those kind of experiences. So we modeled all of those behaviors, and we built in synthetic, almost like robotic transactions, if you like, that run constantly against the farms. So if one database across the entire 37,000 starts to behave slowly because a page in that, one of the pages hosted in that database renders slowly, we know about it. And we know which tenant it was. We even potentially know what user was having the problem. And hopefully we can react to that before the user calls it in. And we do all that through these synthetic transactions, all of these kind of scenario-based things. And then the other thing we do, I mentioned already about the devs getting called out. So the escalation route for Office 365, yes, we have the phone call and you get frontline. Yes, we have, behind that, you get the escalation engineers who handle more systemic issues, long-running problems, frequently experienced problems. Behind them, we have the SP engineering team. So this is the developers. These are some of my peers in the team, the feature teams that I work with, and they're directly accountable for the issues. So one particular lady that I've rang several times when I was in EE for the provisioning system I talked about earlier, she was directly accountable for making sure that got fixed and that process worked. So when people were creating site collections or creating sites, changing user license capabilities, the sluggishness in that system, the poor behavior, the occasional, or the more often than not, the failures in that system, she became directly accountable for it. And if she didn't fix it, she was the one carrying the can, her and her team. So that's kind of how we made this accountable thing. And by making people accountable, we made things happen. We made things get fixed. That's coming out to the call out thing again. And then the final thing is automate everything. When you're in the world of very tight SLAs and very tight financial penalty SLAs, the last thing you need is a phone call goes out to an engineer. Engineer takes a few minutes to log in, takes a few more minutes to request access to the farm they need to get on, takes a few more minutes to diagnose the problem, takes a few more minutes to fix the problem, and then before you know it, you've lost 10, 15, 20 minutes. That's eating into your SLA time, and we have to start paying customers back their money. That's not a way to run a business. You'll very quickly go out of business doing that. So we invested significantly in automation. We have processes that they're hooked into the W3WP process in IIS. They detect long-running page requests, for example, and they send alerts for that. But as well as sending an alert for that, they'll do something else as well. They'll pull the machine automatically out the load balancer. So we say, okay, that machine looks like it's got a problem. Take it out the load balancer. Let's not give anyone else a problem who's accessing that machine. Let's take a memory dump automatically. Let's recycle the box automatically. Let's test the box again automatically, and let's then put the box back in rotation. So that's something that in the old days we'd have to do as an individual person. Log onto the farm, find which machine was running hot or suffering from poor page loads, and then manually pull it out of the load balancer, manually recycle it or take a memory dump, and that all takes time. Now, by the time the engineers even answered the phone call, that's all happened. So the service is almost, in all cases, restored by the time the engineer gets called out. And the engineer just has to come in and validate and make sure it's all done. And that's how we preserve our SLA. That's how we get very close to this zero downtime scenario. In terms of what that means from a monitoring perspective and a capacity perspective, 172 million probes per month. There was a time when Office 365 had more monitoring traffic than user traffic. It was that intensive. 172 million events, scenarios per month is huge. Imagine we have to call the users out, the engineers out that many times. So what we do is we put some smart filtering in place. We have automation, and we use kind of cross-correlation engines to determine how many of those issues are occurring in the same farm, how many in the same servers, the same databases, and we filter them all down. So how many of them are even duplicates? So a slow search load plus a slow page request could be endemic of the same actual root cause. So you don't raise 2 tickets for that. It's 1 ticket if you detect that it's coming from the same place. And we have a lot of smart intelligence in place doing that. So 172 million events come down to 600,000 anomalies. That's still a lot across the estate. 600,000 support calls. We'd need to recruit everyone in this room and everyone at this entire conference, plus 10 times over to handle that level of support incidents. So again, we do it once more and we say, well, what's the severity of those incidents? Are they directly impacting customers right now? And it might be no, it might be one web server's collapsed. Does that impact a customer? Well, at the moment it went down, yes. Now it's out the load balancer and isolated, no. So we filter it down even more. So 200 severity 1 escalations. And a severity 1 escalation can be anything from farmers behaving really poorly, and we can't fix it. This automation of recycling isn't fixing it. There's something else wrong under the covers. Or it could be the provisioning queue is falling over. The provisioning queue is taking a long time. So we filter it down to 200 now. So from 172 million down to 200 actual incidents. It's still too many. You know, ideally we want none. Realistically, you can't have none. There's always going to be something that happens, even down to disk array failures and things. There's always going to be something. But it's a significant reduction in terms of the total number of incidents. The signal to noise ratio drops to about 400%. So from 172 million probes and events, potentially 200 survey calls, and you know, from a relationship or a ratio of how many people get engaged and the disruption to people's lives being called out to handle that situation, it's much less. And these things tend to be known. I'm going to talk in a few minutes about the actual process of what happens when an incident gets raised. When one of these things lands still in my inbox, for some reason, I used to be in EE, and I still get all the notifications. I can't get out of that cycle, unfortunately. But that's not necessarily a bad thing. That means that everyone in the product group is getting these things. We all get notified about the problems. And it's nice when you can look at your mail queue and go, hey, there's no problems today. That's kind of the ideal situation. So what happens when people get called out? So at 2 o'clock in the morning, hopefully this will work. There's a guy in Redmond called Ben Canning, and he is the GPM of the SharePoint data center team.
Hi, this is Ben Canning calling with an important message from the SharePoint Online escalation system.
So when you answer your phone at 2 o'clock in the morning and you hear that, then you start worrying because you know something's gone wrong. That's the automated message, and following on from that, he'll say other things, and it's all automated, and he'll say things like, this farm's broken, users in this data center are having issues, and it basically means get online quickly or this guy's going to be calling you for real, okay? And you're going to that's when you start to feel the pain. And that can happen at any time of the day. The shift leads are the guys that normally get those calls. But then what happens? Well, these things happen. I mentioned we have all these synthetic approaches and we have this customized and very slick automated behavior in how we actually do things. So these emails, along with that phone call, you can go onto your PC, you log on, you'll have an email to match it. So that call will have the phone call you get will have an ID and number in it. In this case, 467809. It is quite old, this. And it gives information about the actual incident that's occurred. And in this case, I don't know if you can read from the back, what we see down here, CFE 6 and CFE 9 taking 0 transactions. They've basically, something's gone wrong on those servers. They've been pulled out of the load balancer. And we, based on our forensics and based on that automated management system, we're 99% sure that these 2 machines are the root cause of this incident. So even though the EE has been engaged and someone is very knowledgeable who could determine this out for himself, the automation is several steps ahead already and can tell him where the problem is. So all he really has to do is come on and validate. And then at the end, we also have, I don't know if this will show, yeah, down here, at the other end of the ticket, we use a system called Cosmos and another analysis system that will also interrogate previous bugs or previous incidents of the same type and provide information for how those ones were fixed. So, hey, we've seen this before. We know the guys that fixed this last time did this. Here's what you might want to do first. So go in and recycle. So they give him PowerShell commands to actually go in and run it. So he can just log on, to the console, run the job, which in this case is restart grid IIS. So grid manager, I'll talk about that again shortly. Grid manager is a very powerful kind of central management function, if you like, within SharePoint Online that can manage all the farms. So we don't want people logging directly onto the farm, so they do everything in a kind of one step away approach. So he logs in, he restarts the IIS machine, and hopefully that'll fix the issue. We get some telemetry, and again, that incident with that resolution gets added to that database and is another tick in the box to add weight to that being the solution to fix this issue. And really, could we have done this automatically? Yes. We could have restarted that automatically, and probably did. But we still want to go in and say, just go in and validate, just make sure. We don't want to leave everything to automation. Otherwise, we're all out of a job. So, as well as that kind of thing, one thing to point out here, we're running PowerShell against SharePoint. We're not running it on the farm. I mentioned this grid manager thing. One of the things we try and do in almost all cases is stop people logging onto servers. People have secure consoles. In fact, if any of you have played with the Microsoft Surface device, some of our engineers are experimenting now with the Surface, which has been custom hardened and custom secured with multi-factor authentication, and that's the only way they can access the system. They can't get there from their normal PC. They have to have one of these secure console devices. And it has to be even down to the fact that in many cases, it even detects the IP that you're coming from and says, why are you coming from that IP? You don't live there. Why are you using your social? If I go to Redmond and take my console with me, I'll get an alert the next day or maybe a few hours after I use it that says, Neil, why are you using your console in Redmond? You live in the UK. Your IP address range is wrong. Has someone stolen it? You know, that kind of thing. These alerts are going off all the time. So I'm very paranoid about making sure that the right people access the right data or access the right machines remotely from the right places. And then these are a bit blurry, these slides, I'm sorry. So I'm going to try and show you some of this. This is some of the tools that our engineers have available. So they log onto the farms, they log onto what we call a jump box or a debug box, which is there's one or several of these in each data center. And they can pull up this tool called SharePoint Analysis Studio. And I believe this is something that we're trying to push out into the public as well. And what it gives us, if you can see on here, is the way Microsoft works. We have our data centers, we have our networks. Within a network, there are multiple farms. And those farms can be content farms, where everyone's databases and everyone's content is. They can be search farms, they can be federation farms, so the various services within SharePoint are federated. And they can go in and very quickly look at the platform and say, well, okay, so I know I had a problem. They can see a date. Like I said, this is quite old now. And they can see, so in this particular instance here, my usage DB availability was 99.57%. Probably means it was offline for a short period of time. They can click on that, and it takes them one step further. If I go back to a red one, so these are the problem ones. You can see we're alerting SEVE incidents at 98% or 97.98%. They can go there, they can click on that and say, well, what's the problem? I'd like to show you this live, but unfortunately I can't get into the system from here, which is probably a good thing. They can then click on the analysis, and this tool, what this tool does, it goes into the back-end storage system where we accumulate all our IIS logs, and it pulls out the right information that's needed to analyze that problem. So which farm is it? Which servers are hosting that farm? Which time period was it? And it goes and runs all this remote data query and brings that information back. And we can do the analysis. So once it's done, we click this button here, comprehensive analysis, or you can do single module. Comprehensive basically means check all of these probes. So I talked about the probes that we had before. Homepage, create document, check the WAC services are working, the window, Web Access Companions. And you can run a comprehensive analysis which will go away and analyze the entire stack, all of those tests, and bring back the data. Or you can do single module. If your alert has been just for one thing, homepage, you can just go filter on homepage. That brings back a number of data, and we get this report back. So like the email that we got before that said what was wrong, what problem had occurred, this is a similar kind of thing. And we can see in here that we had an incident that affected 4 CFEs, or content front ends, web front ends, you might know them as. It affects 83 tenants, and 143 users. not a lot of users for 83 tenants. But immediately, we knew we had a problem in that farm, and we directly know the impact. So 83 tenants and 143 users. It's not a great deal, but it's better. It's more than one. You know, we want these to be zero. So straight away, we know we've got this issue, and we know that it's impacting somebody somewhere. From there, if we scroll down on here, we can do other things. We can do the diagnosis, and we can see what transaction failed. We can see the source of the transaction. We get an ID. This bug ticket is raised for historic tracking purposes. And again, down the bottom, suggested action based on previous bugs. So mining those logs, we can say, okay, we've seen this before, and here's the potential things. Find the broken server and fix it. And it kind of works in a iterative process. As we fix things and as we acknowledge the fact of how these things were fixed, they get added to the database and so on and so forth. And then this is just another one showing a kind of a cleaner one. This is a SQL problem. You can see here we had some availability issues. Could have been deadlocks, could have been some other SQL problem. And we can see here that we had a bad SQL server. Same idea, one major issue. 76% certain that this is the problem. That's high enough for me to go and investigate. And then suggested action is what we would do. So we're not just relying on people logging in and ferreting around to find the problem. We're actually providing significant information. And again, more data there in the report. And then when we look at how things work, other things that we have to do this monitoring for data loss and monitoring for availability and what's going on in the farms is we have these big console monitors. So I'm going to show you later a screenshot of the command center. In the command center, they have lots of screens like this. And what you can see here is kind of a one-pager that's showing the regions from the data centers we talked about. So CH1 is Chicago, Amsterdam, Singapore. GRU is Latin America. SN2 is San Antonio, Dublin, and Hong Kong. Nice and green, except for Chicago. So there's a problem in Chicago. In this farm, we can see the issue here, what's going on. And when we come down here, we can see the incidents, and we can see other things down here, information about what's going on. We can also tell whether, when a ticket's been raised and an issue's in flight, who's been assigned to that issue. In this case, the owner of the ticket here. We can see not only who's been assigned to it, but how long, when did they acknowledge it, how long have they been working on it, what have they tried to help fix it. And then if they're having an issue, they also have a big button in the environment that says escalate now, and they can raise, and basically that says, hey, I'm trying to fix this problem, I'm not quite sure what's going on, and then loads of people get called and it all turns into a massive incident. But it also means that it gets resolved, which is kind of the key idea. So what I'm going to do is I'm going to try and show you a couple of these tools that we have. We've moved on a little bit from those ones. I'm going to show you some of the health dashboards and the SPO Explorer, which is another tool that we have. And the first one I'm going to show you is the replacement one for that health dashboard, and hopefully this will all work. Yeah, not bad. Let me just duplicate. All right, come on. That's getting there. There we go. So you saw the screenshot I showed you earlier. This is kind of the next evolution of that product. And we have buttons across the top that can tell us what's going on. Are there any active incidents? Incident can mean anything from a significant number of people have called in to say that their alerts email aren't going out. That can be classed as an incident. Or we can have a SEV-A. So in this case, we've got 4 active SEV-As, SEV-1s, typically detected by the automated system. And all these tiles are various buttons, and you can notice we're trying to get into the Metro interface here. It's a bit clunky at times, but you can see the same thing. And all these options across the top, we can do various different sortings and groupings. So at any one point in time, even from here, I'm not going to click on these because I could show things I shouldn't, but even from here, I can see what's going on, and I can get some good information and metrics about the environment. And we have other things in here. There's a Windows 8 app that we can get as internally at Microsoft that will tell us where our tenancies are falling down if they are. There's another external web page that we have interface to this. There's all kinds of alerts you can subscribe to. There's just many different ways of getting this information out to the engineers, to the product managers that need to know it and need to be able to focus on it. A couple of other things. Let me show you Office Analytics. Similar kind of thing in here. I can go in and I can look at all the different reports libraries that we have. And this is giving me historic information. So if I wanted to find out, for example, how the social features are working, how many tenants are subscribed to SharePoint Social versus how many have gone down the Yammer route, how many news feeds are we generating, how many articles per month are we generating on different farms, all that kind of data. They take a long time to run. The one I'm going to show you is just the health dashboard down here, hopefully. Or not. This is just a sample. I mean, this is just one example of various different metrics. This is actually showing things like the... come on. Let me put IO Intense on. So what we can see in here is just a sample report. This is grabbed in Excel. It's mining the back end and it's bringing data to the front end. And it doesn't mean an awful lot. It doesn't look very pretty. But actually, it does mean a lot, but it doesn't look pretty. What you can see in here is we're counting things like SQL intensity, which SQL servers in which environment are being hit the hardest, allows us to predict things like potential disk failure. If we're getting a lot of high I/O in one location, it means do we need to think about expanding those disk arrays? So it's all metrics that allow us to think about kind of proactively predicting when we might see failures. So if we've got huge I/O intensity on a certain set of disk arrays in a certain farm for a long period of time, that kind of indicative says those disks are going to wear out quicker than perhaps the ones down here. So it just gives us a view. It's just trying to give you an idea of the things that we're doing behind the scenes. And then as an engineer, there's another tool I have, if I can spell, which allows me to go one step further. So I can run this from any machine. If I want to go deeper in, this machine will give me, if it doesn't do an update, come on. This tool allows me to go in and actually see what's happening in the individual farms from a high level. So I can choose the access endpoint, so where do I want to hop into the environment? Depends where I'm located. I can choose various ones. And I'm just going to look at a couple of internal things. Gallatin is the Chinese deployment. That's the production farms. I'm not going to pull up data about the production farm just in case. And to be honest, if I did, I could only see very high level. If I tried to drill in any further, it would want me to be on a secure console, so it would block me anyway. But if I just connect here, and you can see here, anyone Norwegian in the room? No, all Swedish. The Norwegians wrote this tool, so it works better if you're sat in Oslo, in the Oslo office, as it seems. Those fast guys. This should load shortly. So you can see down the bottom, it's actually saying query and topologies. So what it's doing, it's going out and looking at the MSIT farm. It's looking at eDog. I'll talk about what they mean in a few minutes. And it's going to bring back some telemetry about what's going on. So we can see here, in the MSIT, we can see the network and the content farm. We can see, well, these should start to populate eventually. And it will start to show things like, is there any active escalations? Which monitors? So public site homepage latency, and it will start to give me an instant view of any problems in these environments. So like I say, I could pull up the public site and it would show me all the farms across the world and I get the same information. If I wanted to click in and drill further, I'd have some issues, but you can see here we've got a problem there. The public site homepage availability has dropped to 0. That's not a good thing. Fortunately, it's in our internal farm, not one of your farms. So there'll be somebody somewhere investigating that incident to make sure that that's fixed. But as you can see, don't have to log into the farm, don't even have to go and remote desktop to anywhere else. I can do this directly from my own laptop here. And I can get all this telemetry information. So this is the kind of stuff we're investing in. It's a lot of effort, it's a lot of work, but it means that we can bring all of this data to our own fingertips, to our product managers and engineers' fingertips, that allow us to predict and ensure that we get ensure that we maintain decent service is the whole idea. So, zero data loss. This is really all about business continuity management, and high availability. So the way we keep your data safe. Does anyone know how many copies of tenant data we have available at any one point in time? Does anyone think it's 1? I hope no one thinks it's 1. So we've got a starter for 10 is 4. Anyone, any advances on 4? 10? 10's pretty accurate. 10's pretty accurate. We have data all over the place. Managed and secured, but it's all over the place. Thinking about a scenario. User saves a file. Simple scenario. What do we do with it? Well, the first thing we do is we write it to disk. So it goes through SharePoint onto SQL, into the database. We don't do anything fancy, by the way, with SQL Server. We don't use remote blob storage. We don't use Azure blob storage. We use straightforward SQL content DBs. It's efficient, it works well. There's less complication, less things can go wrong. We're investing in the future. We are going to look at other approaches, especially Azure's blob storage is a route we want to go for highly efficient, low-cost storage. But right now, any of your data is stored as you'd expect it to be found inside SQL Server databases, the way SharePoint always has. So we do RAID 10. That gives us 2 copies of your data. Okay, RAID 10 on the disk. We then mirror that environment. So the entire RAID 10 SQL Server is mirrored to another RAID 10 SQL Server, or another set of RAID 10 disks on a SQL Server in a completely different rack. So not only are we protecting you in terms of copies of data, we're also protecting you from an entire rack failure. So if the whole rack goes down, we're not losing both copies, we've got another copy online. We then asynchronously log ship that. Now we are investing in other technologies, SQL Server always on, high availability, always on synchronous and asynchronous replication. It's a big thing to move our entire estate from log shipping to SQL Server replication. So we have to make sure we plan it carefully. We are investing in that technology. So even though log shipping is old these days, relatively old, the one thing log shipping is very reliable, very efficient, really, very well understood, which is one of the key things in terms of when you're thinking about troubleshooting and simplicity. So it means we can do things very well and very efficiently. We then store another set of your data over here in another rack, in another data center. So if you're located in Amsterdam, if your primary tenant is in Amsterdam, we have this other location is Dublin. So your data is being shipped over there. If you're in Dublin, your data is being shipped to Amsterdam. We don't ship it around the globe. We don't have this, I'm going to say the word Google, but we don't have this Google or Amazon approach whereby they ship your data everywhere. You don't really know where your data is. It's somewhere within their cloud. In the Office 365 platform, because of most of our regulatory compliances mean we can't do that, we have to allow you to know, and we certainly have to know, at any one point in time where your data is. So Amsterdam, Dublin, Amsterdam, Chicago, San Antonio, etc. And then we also do scheduled backups. So we're backing up as frequently as we can, subject to the size of the data. Backups can only run for a certain amount of time. It takes a certain amount of time to take a backup. So we're now into 10 plus copies of your data. So at any one point where that system fails, we've got 10 opportunities to get your data back. Ideally, if this guy failed, you get it back from there. We don't really want to have to be going down here and collecting a database backup from a remote farm, drag it all the way back to a local farm, to reattach it to SQL, to extract your site collection, to restore it. We don't want to be doing that if we can avoid it. Hence, we have all this high availability built in. And then we have another option, which is the recycle bin. So that gives you document level restore, web level restore, list level restore, and allows an admin to do site collection level restore as well. So any of the things that you think about where an end user accidentally deletes something, we can go in here and usually get it back from the recycle bin. In most cases. Doesn't always work, but in most cases. And we are investing heavily in recycle bin capability. So we want to put more and more capability on the end user admin to be able to recover their data, rather than have to be a phone call and then an escalation to get that done. So 10 plus copies of data. That's a lot of storage. 37,000 SQL databases times 10. That's a lot of storage. So how do we do this kind of thing? Well, we have the hot standby, so paired data centers. No one data center is kind of dealt with in isolation. Everything's monitored and tested. So from a data replication perspective, every step of that automated process that's copying your data around their environment is also being monitored. So if the DFSR shares that are doing log shipping from Dublin to Amsterdam start to behave abnormally and go slow, we get escalations. And people get called out to go and investigate and find out what the problem is. So it's no good backing up your data and then not being able to store it somewhere else, because if we lose that data center, we're in trouble. And then our promise, recovery point objective, 1 hour, recovery time objective, 6 hours. I don't know if that means anything to you. Recovery point is the maximum amount of potential data loss from a failover. So if the Amsterdam data center exploded, or as it did the other day, lightning strike, not the other day, but about a year ago, a lightning strike hit the central power line into the data center and took out the whole thing. The act of God, I guess you could call it. We promised to get you back online, or we promised that in that environment, whatever you've been doing, you would lose no more than 1 hour of your data. And realistically, it's much less. That log shipping process that ships your data from Amsterdam to Dublin actually runs about every 13 minutes. So realistically, this value is actually more like 13 minutes, maybe less even, depending on when the backup was taken. And then the recovery time is, we're talking about 6 hours. So 6 hours from a complete data center outage in Amsterdam to bringing you back online in Dublin. And again, 6 hours is the maximum. Typically, we do it in less than 30 minutes. So that's just to give you an idea of how we do it. And those of you that are Office 365 customers, and I'm going to probably hold myself hostage here and say, have any of you actually experienced an outage problem? 1, 2. Okay, everyone's coming up. Hands are coming up now. Yeah, we have problems. Everybody has problems. In fact, any of you that are Office 365 customers are all failed backwards and forwards between different farms at least once a month. Clearly, some of you don't even notice. That's how efficient these services actually work, and how well they work. We test our procedures every month. And that brings us into the lessons learned scenario. So drill, baby, drill basically says, make sure we test your DR strategy. It's something, when we talk to on-premises customers, we've talked to them for a long time. Certainly when I was a PFE, we would go out to customers and talk to them about their business continuity management strategy. And we would always tell them, drill, drill, drill. If you have not tested, validated, and continue to test your backup and recovery strategy, you don't have a backup and recovery strategy. Simple as that. We drill every time. Every single person who's a customer of Office 365 in this room gets tested, full farm failover test once a month, without fail. Everybody, without exception, including our own internal estates. And then no second-class citizen. So we talk about, okay, if you're in Amsterdam, you fail over to Dublin. Well, yeah, you do. But does that mean Dublin's a lower capacity environment? Does it mean Dublin actually has less network bandwidth, or maybe perhaps less efficient machines, which you might do on premises? You might have less powerful SQL servers, or less powerful, less bandwidth capability, or higher latency perhaps even in a DR site, because you're concerned just with functional recovery. In our environment, because we run live customers in both places, they're all first-class data centers. They have the same class of hardware. They have the same class of network capability. There is no, oh, it's a bit slower in Dublin. If you experience it a bit slower, it might be because you're a bit further away, but that's the only reason that would happen. And then other things like resiliency at software and hardware layers. So we build in tons of resiliency. As we saw with a BCM chart before, we're building constantly RAID 10 arrays, multiple mirroring capabilities. We're now introducing new SQL Server technology, like synchronous replication and asynchronous replication, geographic dispersal between data centers. So everything's designed around making sure that we do not ever lose your data. And I know, I worked in Office 365 for 3 years as an escalation engineer, and I only know of one incident where we lost a customer's data. And that turned out not to be our fault. They deleted a site collection, and because we only retained data for 30 days, they rang us back after 32 days. And at that point, everything's rolled off. If you don't notice your site collection's gone for 32 days, it probably wasn't that important to begin with, right? So that's kind of the scenario there. And then thinking about always up to date. So we have approaches within our environment. So we're constantly fixing things. We're constantly changing processes and improving the way we do things. And most of this is done through our scenario where we have to think about trade-offs between constantly patching farms and then the risk that that brings. If any of you have patched a SharePoint on-premises farm, when you suddenly deploy a new CU or a service pack, and about 2 days later someone says, oh, there's a regression. If you deployed that service update, it breaks this. And you'll have seen that in Office 365. We know that's happened. We've patched the farm and something breaks. It's the nature of the business, unfortunately. We try and reduce that as much as possible. So whenever we're doing security patches or platform updates, we have a process now, and the process is improving all the time by regression testing. And every time we patch something, do you know who the first people are that test every patch that Microsoft deploys? The Microsoft people themselves. So we get to feel the pain before hopefully anyone else feels the pain. And in Office 365, we have a whole series of things. Everything's automated. So I mentioned this Grid Manager before. Grid Manager is responsible for controlling which machines we can patch and when we can patch them. And that kind of introduces some quite significant complexity when you think about going from simple scenarios to the kind of scale we operate at. So if you think about a very simple scenario, I've got 2 virtual machines and I want to patch them. They're 2 SharePoint servers in the same farm. They're running identical services. I can switch one off and the other one takes the load. So that's good, right? We're highly available. In a simple scenario, I can lock one down. So I can say, okay, we're not going to touch you because I'm going to patch this guy. And I patch it, and that's good. And then I do the reverse. I lock that one down. I patch the other one. All done. That's great. That's easy, right? No problems. What if I'm more complex now and I have multiple virtual machines on a single physical host? So this is, again, a simplistic scenario, just 2 virtual machines on 1 physical machine. How do I decide when I can install Windows updates and potentially have to reboot that host versus installing SharePoint patches and I just have to reboot the SharePoint machine, or maybe it doesn't even need a reboot? And it gets very complex. So locking these things down, we can patch the entire environment there. So we're doing Windows patches there, we can patch the environment there, and again, we're back to a good state. Take it one step further. Think about our farms. We can have upwards of 100 servers in a single SharePoint farm, spread across tens of physical machines. How do I know when I can patch which machine when? This used to be done by a human with an Excel spreadsheet that looked a bit like this. And he had to start going, well, that machine's in that farm and it's on this host, and I can't patch that one because it'll take down that farm. And horrific, right? So we introduced this thing, Command Point. Command Point monitors everything. It knows where the VMs are. So if you look at the Farm 3 here, for example, it knows that the virtual machines for Farm 3 are spread across these physical machines in different racks. And again, we do that for resiliency reasons. So it knows that if I want to patch my boxes, these 2 physical machines don't have anything for Farm 3, so I can patch those 2 without taking Farm 3 down. So they get patched, and so on and so forth. And that's how the automated, let's go back there, but that is how we kind of automatically control which machines can be patched when. It's all done with a ton of logic inside this Grid Manager. Grid Manager took 300 developers 3 years to create, roughly. So we have had big enterprises come along and say, we want to do what you do. Can you show us how you did it? We show them, and then they go, we don't want to do that. Because the investment is huge. So think about how we do these patches and how we roll out changes. And I said already, Microsoft people, we feel our own pain. So when we think about what we do here, think about the testing that goes on. Developer does testing, has their own integration test suite. We have our integration test suite for the Office 365 platform. We then go one step further and we deploy to this thing called eDog. eDog is kind of one step away from the MSIT platform. So it's one step back from the Microsoft general population. It tends to be people like me, people like Nicholas, who are in the product groups. We get to invest and we get to experiment first with these things. So we get to feel the pain before the wider Microsoft audience feels the pain. So if there's a recent issue with a build of Office, for example, that's got an Outlook problem with it that continually drops from Exchange, we've detected the problem here. So it's not going to get there, so none of you are going to notice this. It won't be deployed to your environments. We feel it down here, we suffer, we complain. I've got my boss, in fact, can only use Outlook Web Access right now because his Outlook client on his desktop's completely screwed up. Okay, and that's kind of one of the problems we're facing. But it means that we detect it here, means it gets fixed here, it gets rolled right back to the developer, gets fixed and rolls forward again. We then come to the Microsoft tenancy, so our own My Sites, our own MSIT internal platforms, our own portals and line of business applications, all run one step back from production. So another level of testing. We open it out from eDog, which is running probably 10,000 people testing it, to the Microsoft tenancy. We've now got 150,000 people doing that same level of testing. So more things get detected. Problems get fixed, problems get rolled back and reiterated again. Then eventually when we have no, and I'm going to say no detected problems, I'm not going to say no problems at all because it's software, right? We then roll into production. So we try as best as we can, this is our kind of test matrix, our integration process, if you like, that we bring you a product that hopefully has been tested by people doing the same things you want to do with it, and any problems have been resolved. And I've just got an Office update telling me to install a new version of Office. Anyway, that can go. So the final thing I want to talk about really is secure and compliant. So how do we secure what we have, and how do we protect your data from everybody else and your data from our own internal people? Okay, there's a big issue. You know, obviously we don't want our own admins, our own engineers logging into your environments and taking data. So we have inside Microsoft a team, and their entire job is doing detection. And they detect things like vulnerabilities, patch compliance. Yes, it only says 98.3% patch compliant. If any of you have done IT operations, that's actually really good. I've never seen anyone be 100% compliant. But we've detected the gap and we fixed the gap. We keep rolling. Because by the time we install these fixes here, there's another one been released and we're not compliant with that one. But you get the idea. We're moving constantly. And there's total a team and they're devoted to penetration testing. They're devoted to vulnerability testing. They even do phishing testing against our own staff. Right? We recently sent out an email to all the engineers in our Office division saying, fill your name in here and get an Xbox One. Looked like an official Microsoft email. Loads of people go and click on it. Then when you looked at it, it was like, well, maybe not. Now it's asking me for my username and password on a form, an unsecured form. Why do I want to do that? But it looks real. It looked like one of our normal communications. And it was our security team performing phishing attacks against our own engineers to find out who would put their username and password into that form. Right? And when they did, they got a nice little email saying, do you realize what you've done? Okay, and if you realized it was fake, you could actually get something for detecting it was fake. So and this is happening constantly. We're constantly making our own people vigilant so that we don't expose our own levels of access. As it happens, the username and password is no use to anybody without the smart card that goes with it and the PIN that goes with the smart card, but we don't want to be exposing that anyway. In terms of protecting data, if we think about the security that we have, I'm just conscious of time, I've got 4 slides or so. The admin here is you, the IT admin, the tenant admin, if you like. And in terms of data access, you have access to core data. Okay, so you can access your own data in your own tenant, in your sort collections and document libraries. Our debug engineers can only access the back end. So they can access the workflow, they can access the SQL logs, they can access our data systems and our analysis systems, they can pull ULS logs off farms, they can get telemetry data from CPU resources and memory and that kind of thing. They can't get access to the data. Okay, they don't have the rights to do that. There are a very tiny core group of people who have what we call standing access, and they can access everything. That number of people is less than you can count on one hand. Okay, and they're the most highly trusted available people. And we have to have a number of people who can do that, because if something breaks significantly, we need people who can just get there straight away and start fixing it without jumping through the hoops of, I need to request access to this and request access to that. Those people tend to, if you're in the US, if you're a US tenant, those people will have been screened by the FBI before they're allowed into the system. So that's the kind of level of approval we give people, and the level of compliance we have in terms of making sure that the right people only can access the data. In terms of our compliancy, some of these won't, well, HIPAA, most people know what HIPAA is, and the ISO 27001 is talking about our audit policy and tracing and tracking. There's nothing anyone does in Office 365 as an engineer or as a product manager, whatever you might be doing from a Microsoft perspective, everything we do is tracked. Every machine we log on to, every command we issue at the Grid Manager command console is trapped, detected, even down to things like what processes am I running when I log on. If I logged onto a system and spun up ULS Viewer, then people would be asking questions. Why is he running ULS viewer? We don't need that. We can do remote connection for ULS logs. So they start to ask questions. But in terms of the security, we do all of this kind of thing. So we're detecting and making sure we're being incredibly compliant. And sorry, these are the kind of reports that people get. So this person here, and that's a guy called Sam Crusden, ran T-list on that server. And it gets flagged and detected, so we know when and why and who and what. So it's just all about, again, detecting and security and remaining compliant. And at the back end of everything, we have this huge thing called Cosmos, which is a massive big data engine. It's the same data engine that Bing uses for all of its recommendations capabilities. And this is where things come from, where we things like suggesting fixes and suggesting this, that, and the other. It all comes from this enormous data warehouse that's pulling telemetry data and pulling logs in from all different environments. One thing the engineers can do, we can query, go back, if you're familiar with ULS logs, we can query up to 3 years of ULS logs from any correlation ID in less than a second using this process. Now, if you've done that before, you know how painful that can be. That's the kind of engine we've got. And it's all about ensuring that, again, we can fix things, we can access problems and detect problems and determine how to fix problems as quickly as possible from our historic data. The other reporting engines we have, I mean, I won't spend too much time on these. I've only got about a minute left, if that. We talk about things like desktop browser distribution there. Is just one report. So the data that we get from Cosmos will actually tell us what our users are doing as well. What browsers they're using. How often do they use this feature? How often do they use the other feature? Do we need to invest time and effort in making that feature better? Are people not using it because it doesn't work a certain way? So it allows us to mine information and pull out user behavior so we can predict where we need to invest for the next budget in terms of what we're going to invest in for the product. Final things really, the command center. This is the heart of the whole operation. There's a number of command centers around the globe. That's the one sat in Building 16. Building 16 is the development center for SharePoint in Redmond. And you can see here, these are these dashboards and things I showed you very briefly. These are kind of different ones. This one is actually the SharePoint dedicated one. And every green square represents a healthy farm. And every red one obviously means there's a problem. But you get the idea. These guys sitting here, this room is secure. Only certain people can get in. They have their own food and drink capabilities inside that room. They can be locked away in there for 12 hours on shift, and you don't see them again till the next day. And in the buildings, there's also a kind of a failover room as well where they can go. If for some reason network connectivity got severed in this room, they can go to another room and perform the same function. And we have equivalent centers in Winnipeg and China and various other places. So that's the whole idea. So it's a bit of a whistle-stop tour. Any one of those sections we could spend a whole session on, just going deeper into it. But I wanted to give you a view of how seriously we take the whole operations thing, because it isn't a traditional business for Microsoft. It's becoming one, but it hasn't been for a long time. So with that, any questions, and then we're done. Question?
Talk about the release process.
Yep.
Do you require a response from the testers, or is it kind of a silent accept if you don't get any reported?
So the question was about the release process. So basically, if we fix a feature or deploy a new feature, that thing. So the testers have to fill in a form that meets the requirement that says, is it secure by design? Does it meet all of these things? Is it functionally correct? Does it introduce any other problems? But we have an enormous internal integration engine as well. There's an internal website, if any of you are Microsoft employees in the room, called Office Pipe. And you can log on to that site and you can actually see these builds in flight. And you can see what tests have been completed, what tests have failed, what tests are successful, what tests are dependent on other tests. So throughout every step of the way, we're testing all of those things. So at the developer level, at the integration level, when it reaches MSIT or reaches the EDOG environment, we're very much more dependent on user feedback at that point. But certainly from a developer perspective, if the developer detects any problems, they have to sign off on their feature. It has to go up the developer management chain to get signed off before it starts to get deployed. And if it
That's given, but I was actually asking just about the EDOG and the Microsoft kind of a community in that stages.
So at EDOG and at MSIT, it's very much based on user feedback, because at that point, in terms of automated detection, we've done as much as we can. We're then a case of dependent on the user and how the users feel the product's working, whether it breaks under certain circumstances. We have to get feedback from the users at that point. Any other questions? No? One more?
Regarding backups.
Yep.
Well, you have like 10 or plus copies, you said. For how long are data stored?
So the question is for how long do we store backups? So the 10 copies of the data that you referred to are 10 copies at various points in time. We only realistically have, if you think about the backups, it's like one copy, if you like, but it extends for 30 days. Excuse me. So every time we take a backup, we store it for 30 days, and then they roll off. So you can go back, you can request to restore going backwards 30 days.
Even if the backup is in number 9, so it's not 30 days multiplied 10 copies.
Yeah, excuse me a minute. Sorry. Yeah, so the backup, when we take a backup, we back up from SQL onto a file share. That file share data is then replicated to an off-site or the other data center, if you like. And each backup is retained for 30 days. So when you're partway through that process, let's say you're in the asynchronously replicated location in the secondary data center, we won't keep 30 days there because that's all in-flight live data, right? It's 10 copies of the data. So if you say 10 copies and one of them's a backup, so 9, it's 9 copies of data as it looks today in flight, plus 1 copy that's historic going back 30 days. Does that make sense? Yeah? Okay. Any other questions? I'll let you go for coffee then. Thank you. Thanks very much.